In this video, we're going to be doing some more extra problems from Module 4. We're going to be focusing on sections 7.5 and 7.6. 7.5 is solving rationals in equations, whereas before we were doing rational expressions. You start out kind of the same. You're still looking for the LCD. So we're looking for the LCD of all the fractions in the equation. In this equation, there happens to be two fractions. And then we want to look at the denominators and determine if we need to factor them. So y plus 9 is already factored, but 2y plus 18 could factor to 2 times y plus 9, right? They both have a 2 in common. So now you can see that the first fraction is a factor of the second fraction. This y plus 9 is already there. So the first one would just need a 2. So our LCD would be 2 times y plus 9. Now, instead of multiplying the first one by 2 over 2 and getting a common denominator, we're going to multiply both sides of the equation by this least common denominator. What this is going to do is cancel out our fractions. It means that we're not going to have to work with fractions. So we kind of did this in Module 2, but without expressions, right? Without letters and stuff. It was mainly numbers. So what we're going to do is we want to multiply each term. In this equation, there are 3 terms. 1, 2, 3. This is a term, this is a term, and this is a term. And we're going to multiply each of these 3 terms by the LCD. Okay? So I'm going to go ahead and write it out just to show you exactly what's happening. And we're going to put it over 1. So we remember that we're trying to multiply the numerator of the fraction by this. We don't want to multiply the denominator. And then make sure also that you multiply the other half of the equation by it. If you don't, you will not get the correct answer. You need to multiply both sides of the equation by this LCD. Everything gets multiplied by it. So now I'm going to go ahead and just write it out. I'm not actually going to multiply anything. I'm going to write it, though, as a single, each term as a single fraction. And I'm writing this second denominator in the factored form. And now I want to look at what they have the same, right? Because we've already learned that anything over itself is equal to 1. So whether it's 3 over 3, it equals to 1, right? If it was x over x, it would still be equal to 1. So now in this problem, it's particularly y plus 9 over y plus 9, still equal to 1. In the next term, they both have the 2 times y plus 9 over 2 times y plus 9. And those cancel. The last one is not a fraction. So now what we want to do is go ahead and multiply out what we have left. So in this first term, we have 6y times 2, which gives me 12y. Next term, we have plus 18. This sign comes down, whatever sign is here, plus this 18. And then over here, now we need to be careful when we're multiplying. Remember, we multiply left to right. So I just want to multiply the 7 and the 2. I do not want to distribute the 7 into both of these. We will distribute after we multiply the 7 and the 2. So it's equal to 14 times y plus 9. Okay, so now I have 12y plus 18 equals to 14y plus 126. Okay, so I distributed this 14 all the way through, the y and the 9. Okay, now I need to just solve for y. Now it's a basic equation and I can just solve for y. I'm going to do minus 12y and minus 12y. That'll keep my y's positive. So I get 18 equals 2y plus 126. By minus 126, minus 126, I should get a negative 108 equals 2y. Divide by 2, divide by 2, y equals a negative 54. Okay? Now please remember, when you're doing rational equations, you do need to come back up to the top and plug your answer back in, right? Because if this answer, this y equals negative 54, so if negative 54 when plugged in gave me 0 in the denominator, then that would be undefined, and it would have no solution as the answer, because you can't get 0 in the denominator, right? We talked about domain, so that number would not be in the domain. Negative 54 works, because if you did negative 54 plus 9, it would be a negative number, but not equal to 0. And 2 times negative 4 plus 18 would still be a negative number, but not equal to 0. So we just don't want the denominator to be equal to 0. Okay, so here's another example. 2 plus 3 over a minus 3 equals a over a minus 3. Again, we want to start out with our LCD. This one's a little bit easier to see the LCD because they have the same denominator, right? The two fractions have the same denominator, so the LCD is just going to be a minus 3. But again, we're not going to try to combine these fractions. We're going to try to clear the fractions. So we're going to take each term, 1, 2, 3 terms again, and multiply them by the LCD. So this time it happens to be a minus 3. And I'm writing it all out. As you get more comfortable, you can start trying to maybe combine steps, or see how you get comfortable with it. I'm going to write it all out so we can see exactly what's happening. Okay, so again, now we're looking for things that show up over themselves. So here we have the a minus 3, they cancel out. Here we have the a minus 3, they cancel out. This is our goal in this process, is trying to eliminate the fractions. If the fractions don't get eliminated, then I would be kind of concerned and check and make sure that I didn't make a mistake, or it should be a red flag for you. So this one I'm just going to bring down. 2 times a minus 3. This sign comes down again, plus this, there's only a 3 left here, equals an a. And again, now it's basic equation solving. So we're going to distribute this 2 all the way through. 2a minus 6 plus 3 equals a. Negative 6 plus 3 can be combined, so that would give me a negative 3 equals a. Here again, we can subtract the a from here. Now, be careful with this, because what will happen is sometimes students will do it this way, right? And so this one becomes a, but they don't know what happens over here. If I had an a and I take an a away, it's equal to 0. Don't make it equal to 1 or a or something else. If you don't feel comfortable with this, you don't have to solve it this way. You can instead subtract 2a from both sides, move the 2a over here, right? Then I get negative 3 equals negative a. 1a minus 2a's give me a negative a, and now I can just divide both of them by a negative 1, and it will give me a equals 3. And this would be my answer. But what are we supposed to do? Hopefully you're saying, check it. Yes, we're supposed to take it back up and check it. And this answer, if I plug 3 in for a, right? So if I take my original equation here, and I say that 2 plus 3 over my answer, 3 minus 3, equals 3 over, because everywhere there's an a, it's now a 3. I'm checking my answer. My answer was a equals 3. I'm plugging that a in, that 3 in for all the a's. And you see what happens here on both the denominators. I get 3 minus 3, which is 0. 3 minus 3 is 0. All it needs to happen is once. If you get a 0 in the denominator, right? If you get a 0 in the denominator, even once, then it's no solution, because the solution we found does not work. So the answer for this one should be no solution. If you put 3 in, you're going to get it wrong. You may get points back if you show all your work, but you're going to get it wrong because the answer was actually no solution. So please make sure you remember, whenever you're solving rationals, that when you get your answer, you take it back and plug it in to the original equation to find out, does this give me an answer, or does it give me undefined? Okay, so now moving into 7.6 is the word problems, where we're using some of this rational expressions in word problems. So the first one says, in 33 minutes, a conveyor belt moves 300 pounds of recyclable aluminum from the delivery truck to a storage area. A smaller belt moves the same quantity of cans the same distance in 24 minutes. If both belts are used, find how long it takes to move the cans to the storage area. So the first thing you need to do is organize this information in a way that makes sense, that you can do something with it. Right now there's a lot of information, 33 minutes, 300 pounds, 24 minutes. What does this mean for us? So the first thing we want to do is say that we're talking about the large belt versus the smaller belt or small belt. Okay, and we want to know how long it takes to move the cans to a storage area if both belts are used, right? So if they're both working together. And the common mistake people make is they say, oh, well, 33 plus 24, yeah, it'll be 57 minutes, and that's when they'll be done. But that doesn't make sense logically, because if one can do it in 33 minutes by themselves, and another one can do it in 24 minutes, if you put them together, it shouldn't be more time. It should be less time. You also can't add them together and divide it by 2, because that would imply that they're doing the same amount of work. And obviously the smaller belt is doing more work because it does it faster. It does the same job in 24 minutes versus 33 minutes. So we need to break this down into an increment that makes sense. The way we want to do this is we want to start by making a chart, right, to organize what information we're given and what information we need. So we have the large belt, the small belt, and then the two belts together, right? And we have the time it takes them to do the job alone. And then what we're going to do is we're going to break it into an increment that where we can compare them against each other, right? So what we're going to do is in 1 minute. And this could really be any amount of time. Like you could do 1 hour if you were talking about hours. You could do 2 minutes if you want. But 1 is the easiest because you're making a fraction. You're saying in 1 minute, what percentage of the work would be done? What fraction of the work would be done? So the large belt moves the 300 pounds in 33 minutes. We're not actually concerned with the 300 pounds. We just need to know that the smaller belt's moving the same quantity, so that these two are the same amount of stuff that's being moved. So the large one does it in 33 minutes, the small one does it in 24 minutes. Together is what we don't know, right? That's what we're going to call our X, because we don't know how long it would take them together. And then we want to break it down into the smaller increment, the same amount of time, how much of the work would be done. The large one would get 1 out of 33. Right? Because in 1 minute, if it takes 33 total, it would be 1 out of the total. The small would be 1 out of 24, and together would be 1 out of X, right? And now we can make our equation. We can say that if I take 1 out of 33, that's the amount that the large one would have done in 1 minute, plus 1 out of 24, the amount that the small one would have done in 1 minute, is equal to my 1 over X, the amount of time it would take them to do the total job. Okay, so now again, I want to look at my LCD because I can clear the fractions and not have to work with fractions, right? So I'm looking at my LCD. There's nothing in common for 33 and 24, so you have a little handy calculator. You do 33 times 24, gives me 792X, because I have 33 times 24 and the X. And then I'm going to multiply this by each term, right? Again, equation solving with expressions. So I want to multiply every term by this LCD, my goal being to eliminate the fractions. So if you do 792 divided by 33, you would get 24x, plus 792 divided by 24 is 33x, equals 792x divided by x, my x's will cancel, so equals 792. Now it's basic equation solving. You can just get 57x equals 792, divide by 57. Now here again is where you're going to run into another issue. X is going to be equal to, if you put this on your calculator, 792 divided by 57, you get 12.7894736.8, and it keeps going, right? But my math lab doesn't generally like decimals unless it specifically asks for a decimal. You should not go to a decimal and round. So instead, what we need to do is see what they have in common. Are they both divisible by some number, right? And these two happen to both be divisible by 3. So if you do that, you get 264 over 19. This would be your simplified answer. You would be finished. A lot of times it says you can go to a mixed number, and if you want to, you can, but you don't have to. Now, if you get this answer and then you make a mistake going to the mixed number, you're probably going to lose points because now you made a mistake versus this answer also being correct. So I would just stop here if it were me. So the last one we're going to do today is a distance, rate, time one. And so a pilot can travel 416 miles with the wind in the same amount of time as 336 miles against the wind. Find the speed of the wind if the pilot's speed in still air is 235 miles per hour. And I really want you guys to think about this because this is one that a lot of people make mistakes on. And if we were in class, I would show you a video of people trying to run against the wind because it's funny and it kind of puts it in perspective to you. If you are walking or running or whatever and the wind is blowing, are you changing the wind's speed? Hopefully you're saying no. No, the wind may slow me down or the wind may push me faster, but I can't actually slow it down. So I want you guys to kind of think about too like a hill, right? When I'm going up the hill, I'm going slower. It's slowing me down. And then when I go down the hill, it's pushing me faster, right? It gives you that extra momentum. The wind is the same thing, but it's really important to remember, is the wind, am I changing the wind or is the wind changing my speed? So we have two different things. We have with the wind, and then we have against the wind. Okay, and we're going to do a chart again. We hopefully know from Module 2, distance equals rate times time. Spread it out a little more, give myself more room. Okay. And so now we need to fill in the information that we know. So a pilot can travel 416 miles with the wind. So that's my distance, 416 miles, in the same amount of time. So that's telling me my times are equal. So I like to put that little equal sign there as 336 miles against the wind, right? Again, the wind pushing you faster or slowing you down. And then it says, find the speed of the wind if the pilot's speed in still air is 235 miles per hour. So again, I'm either getting boosted by the wind or I'm working against the wind. So I want my speed 235 plus the wind or 235 minus the wind. The wind is either pushing me faster or slowing me down. It's not the wind plus my speed. That would imply that I am making the wind go faster, or I am slowing the wind down, and that's not logical. So now I need my equation in form of time, so I'm going to take the original distance equals rate times time, and I can solve this equation for t, for my time. Divide both sides by r, so my time is equal to my distance over rate. So that's what I want to put here in my time box, 416 over 235 plus w. And 336 over 235 minus w. Okay, now I can make my equation. These two, the times are equal, so I can say 416 over 235 plus w equals 336 over 235 minus w. Right? Now it's just a proportion, so it's even easier than multiplying by the LCD. I can just cross multiply these two. So I get 336 times 235 plus w equals 416 times 235 minus w. Okay, so now I'm going to distribute my 336 into both pieces in here, and these are going to be kind of big numbers, but you have a calculator. So 336 times 235 gives me 78,960 plus 336W equals 416 times 235, distributed in, right? So 97,760 minus 416W. So now I want to solve for W, solve for my wind speed. What I'm going to do is add 416 to both sides, which gives me a positive W. It would work out either way that you solved it. It's just a personal preference. So I have 78,960 plus 752W equals 97,760. Subtract my 78,960. Okay, 752W equals 18,800. Divide both sides by 752. So W equals 25. And now I want you to think about this. Does this answer make sense? Well, first of all, what am I talking about? Oh, I'm talking about a wind speed. Then yes, 25 miles per hour for a wind speed does make sense. This is a reasonable answer. If you get something really bizarre here, I would be concerned. If you got 250, I would be concerned. I would go back and check my work. If I got 2.5, I would probably still be concerned because that's really low for the wind speed when you're talking about a plane. So just check and say, does my answer make sense? Is it logical?